In section 5.1, we're going to be looking at exponential functions and their graphs. So our topics today are going to be the definition and classification of exponential functions. What does an exponential function actually look like? We're going to be talking about graphing these exponential functions. Okay, the parent graph, we're going to be talking about how they increase or if they decrease, and then we're going to be talking about their shifts. We know that graphs can have vertical shifts, horizontal shifts, they can be reflected, all of those good transformations to the graphs. We're going to be solving these exponential equations, and then we're going to be inputting exponents and graphing exponential functions. So, really quick, what is an exponential function? It's any function in the terms of y where we have an exponent where the exponent is x. We have a base. Again, a here is called our base, and again, that's going to be a number, and then x is our exponent. That's what makes an exponential function, when our exponent contains x. So we have some behaviors of these exponential functions. Again, this should be a review from Algebra 2, but our base, or here our a value, our big number here, that's our base, tells us if our function is increasing, decreasing. Okay, if a, our base, is between 0 and 1, which means that it is a fraction or a decimal between 0 and 1, like 1/2, 2/3, 3/4, anything like that, then we know that our function is decreasing. Okay, so if we have a fractional base that is less than 1, okay, so don't get confused about that. If my fractional base is less than 1, then my function is decreasing. Now, if my base is larger or greater than 1, so if I have a base of 3 or a base of 7 or even a base of 5/2, 5/2, okay, it's still a fraction, but it's bigger than 1, then my exponential function's increasing. That means it's growing, it's getting bigger. For all of these basic a to the x functions, we have a point that lies on our graph at 0, 1 for all of these. Now, when we start transforming them, moving them left, right, up, down, reflecting them, things like that, that point can move, and we're going to talk about that in a little bit. But all of these basic a to the x, 5 to the x, 1/2 to the x, they all have a point that crosses at 0, 1 on our graph. Okay, so let's talk about some of these functions, and then we're going to look at what do their graphs look like. And again, you can always use your Desmos calculator to look at graphs. So this first one, f of x equals 3 to the x power. Is this function increasing or decreasing? Well, we get that by looking at the base, and here our base is 3. So since it's greater than 1, this function is increasing. And since we're not shifting it or reflecting it, it will have a point at 0, 1. So I do know it has a point at 0, 1. Can we find some more points? Yes, we definitely can find some more points very easily. We can do an XY chart and we can plug in some more points. So I already have a point at 0, 1. Let's plug in some more x values to get out y's. Let's plug in 1. Let's plug in 2 and just see what happens. If I plug in 1 for x, 3 to the first power is just 3. And then if I plug in 2 for x, 3 squared is 9. So I've got some more points here, 1, 3, and 2, 9, that I can possibly graph to see what this thing looks like. Could I have plugged in 0? Yes. Well, we already did because we got the point 0, 1. Could I have plugged in negative numbers? Yeah, I could have plugged in -1. 3 to the negative first power. 3 to the negative first power. We know anything to the negative power, we can't have a negative exponent. So in order to get rid of it, it goes to the denominator. So it's going to give me 3 to the first in my denominator under 1. So that is just 1/3. So there again, I've got another point, -1, 1/3. So I'm going to flip over and we're going to look at the graph really quick. It is graphed on this next slide. Here are some of those points that I already found. We said that the point 0, 1 was definitely going to be on there. Here's my point 1, 3. Here's that point -1, 1/3. And again, if I look at this graph, since it is going up from left to right, it is increasing. And the whole reason it's increasing is because our base is bigger than 1. Okay, let's go back and look at B. G of x equals 1/2 x. So what do we know here? I'm going to look at my base, 1/2. Well, that is between 0 and 1. So that means that this graph is decreasing. It's going to be going down from left to right. We read a graph just like we read a book, from left to right. Since this thing has not been shifted left, right, up, down, or reflected, I know definitely I have a point at 0, 1. We're going to find few more points by plugging in into an XY chart. I'm going to plug in, I've already got 0. I'm going to plug in 1. I'm going to plug in 2. I'm going to plug in -1. If I plug in 1, 1/2 to the first is just 1/2. 1/2 squared, that means 1/2 times 1/2, which is 1/4. 1 times 1 on top, 2 times 2 on bottom. And then 1/2 to the negative first. Remember, I can't have a negative exponent, so I flip that fraction to get rid of it. So that gives me 2/1, which is just 2. So I have the points 1, 1/2. I have another point of 2, 1/4. And I have another point of -1, 2. So I can go and plug or plot all of those points on my graph. And we're going to go to the next page and look at it. And here are all of my points that I just found. That 0, 1 we knew was on there, -1, 2, and that 1, 1/2. Again, since this thing is decreasing, it's going down from left to right, it is decreasing, and the whole reason it's decreasing is that base is between 0 and 1. It's that fraction. Now, let's talk about the transformations. How do these things slide around on our graphs, moving from left, right, up, down, all that good stuff. So if you remember, if I have a function, f of x equals, just say -a to the x minus h plus k. Okay, so here are all my transformations. Remember, if there's a negative in front, that reflects over the x-axis, reflects my whole graph. This minus h here is my horizontal shift. And remember, with those horizontal shifts, it's backwards. So if it's like x plus 2, I'm actually shifting to the left 2. If it's x minus 4, I'm actually shifting to the right 4. And then the k at the end is my vertical shift. If I'm adding 2 on the end, then I'm moving my whole graph up 2. If I'm subtracting 5, then I'm moving my graph down 5. So we're going to look at these. First, I want to go through and let's just see, can you tell me the transformations? And then we're going to look to see how they affected the graph. So f of x equals 1/2 to the x plus 3 power. Okay, well, the 1/2 tells me that this graph is going to be decreasing. So I know that it's going to be going down from left to right. the x plus 3 up here, since I'm adding 3 in the exponent, that's my horizontal shift. Again, that one's backwards. Since I'm adding 3, I'm actually going left 3. Okay. Now, we're going to look at these one at a time, so I'm going to be flipping back and forth. So I'm going to go to the next slide. Here is that original in green here. Dotted in green is the original. We actually just plotted it a few minutes ago. The dotted green line is the original parent function, the 1/2 to the x power. Now, I'm going to take all of those points, and all I've got to do is move them. My thing is still decreasing. That hasn't changed, but all my points are going to move 3 units to the left. So if I take this unit, -1, 2, I'm going to move it 1, 2, 3. Okay, if I take this point 0, 1, I'm going to move it 3 to the left, 1, 2, 3. And then this last point of 1, 1/2, I'm going to move it 1, 2, 3. So everything moved 3 to the left, giving me my new function. Okay, B. Let's go back to B. G of x equals -3 to the x plus 1. Well, if you go back, we already did 3 to the x in that very first example. We said it was increasing. Now, I always have students that get this wrong. This negative does not change the increasing, decreasing. Okay? It just reflects. So, since my base is still +3, this thing is increasing. But the negative sign makes it reflect over the x-axis. And then nothing's being done with x, so I have no horizontal shift. But I do have a +1 out here on the end, which is my vertical shift. So this thing is going up 1 unit. Now, let's look at the graph. So I'm going to flip over here to B. So you're going to go over 2 more slides. Again, in the green was my original. We already graphed that earlier. So I'm going to take all of these points in green, and I'm going to do these transformations. I'm going to reflect them, and I'm going to move them up 1. Okay, so if I take this first green point right here, if I reflect it, I'm going to kind of do it in red. It would be down here because I'm reflecting over this axis here. And then I'll move it up 1, which puts it right there on my graph. This point 0, 1, I'm going to reflect it over my blue dotted line over my x-axis, which puts it down here at -1, but then it moves up 1. So there it is on my graph at 0, 0. And then my last point of 1, 3, I'm going to reflect it again over my x-axis or my blue dotted line. 1, 2, 3, so I'll move down 1, 2, 3. But then I move it up 1, so it's here at 1, 2. And so this then is my new function. And don't forget, you can always graph these things on Desmos and look to see what they look like. And the last one, h of x equals 2 to the -x power. Now, I got to be very careful. I cannot have a negative exponent. So, I'm going to first rewrite this problem. H of x equals 2 to the -1 times x. I'm just separating -x is just -1 times x. I cannot have a -1 as an exponent. So we already talked about 2 to the -1 power. I take the reciprocal or make this a fraction to get rid of the -1. So the 2 to the 1st is going to go to the bottom under 1, which is going to give me 1/2. So this function is actually going to be h of x equals 1/2 to the x power. Okay, so let's talk about this function now. What's it doing? Is it increasing or is it decreasing? Well, we look at that base. It is less than 1, so it is decreasing. Okay. And then I'm going to look for my shifts. I'm not reflecting because I don't have any negatives anymore. I don't have a horizontal shift because nothing's being added or subtracted to my exponent of x. And I have no vertical shift. So all this thing's doing is just our basic function. If we go back and look at C, our original was f of x equals 2 to the x. So all this thing did was just reflect everything over. Okay. And again, we can see here that this whole thing is decreasing instead of increasing. Okay. Now, how do we solve exponential equations? Okay. Through a few steps. These are not hard. Again, it's a review from Algebra 2. First step, we're going to isolate, which means get by itself, the part of the equation that has the exponent. So like 2 to the x power. I want that all by itself. Move the exponential containing x to one side of the equation and any constants or other variables to the other side of the equation. This is where we have to get like bases. Okay. Once we rewrite our problem where both bases are 2 or both bases are 4, like bases, then all I have to do is take the exponent part, set them equal, and solve. You should remember this from last year. So let's look at some of these. There's going to be 3 that we look at. So the first one, 25 to the x power minus 125 equals 0. Well, first thing I have to do is I have to get this 25 to the x all by itself. Okay, so I'm going to come back over here. To get the 25 to the x all by itself, because it says to get that exponential part isolated, I'm going to add the 125 over. I'm going to get 25x equals 125. Okay. Exponent has been isolated now. Next thing is to get my bases the same. Okay, sometimes all I have to do is change one base. Okay, sometimes I have to change both bases. Here I'm going to have to change both bases. Both of these can be changed into a base of 5. So this is actually 25 is 5 squared. And then I'm going to have times x because that still stays in my exponent. And then 125 as a base of 5 is 5 to the 3rd power. Now the whole reason I did that is my bases are now the same, both 5. So I take the exponential part, the 2 times x and the 3, and I set them equal to each other. 2x equals 3. And I'm just going to solve for x, divide both sides by 2, and x equals 3/2, or 3 over 2. Okay, let's look at B now. B was 8 to the y minus 1 equals 1/2. Okay, first thing, my exponential part's already all by itself, so I don't have to move anything, but I am going to have to get these with the same base. Okay, so if I look, one base is a whole number 8, one base is a fraction, 1/2. So I'm going to need to change. I can do one of 2 ways. Either both of my bases need to be whole numbers, or both of my bases need to be fractions. Now, I like to work with whole numbers more than I do fractions. So I'm going to rewrite this problem as 8 to the y minus 1 equals. Now, I can take this 1/2 and I can rewrite it as a whole number. I can take this 2 and I can move it to the numerator, but in order to do that, it goes to the negative 1st power. So this 1/2 is going to be changed to 2 to the negative 1st. Now, if I look I still don't have the same base, so I'm going to have to change to the same base. The 2 is already as low as it's going to get. I can't do anything with that side to the negative first, but I can change 8 to a base of 2, and that is 2 to the 3rd power, and I still am going to bring down that y minus 1. Now that I have the same base of 2, all I have to do is take my exponent part and set them equal. So I'm going to get 3 times y minus 1 equals negative 1. And I'm going to solve. Distribute my 3. 3y minus 3 equals negative 1. Add my 3 over. 3y equals 2. Divide by my 3. And y equals 2/3. Okay, C. 2/3 to the x equals 9/4. Well, since they're both fractions, I know we don't like working with fractions, but we're going to leave them as fractions. So I'm going to rewrite. I don't have to move anything because everything's, the exponential's by itself. So 2/3 to the x. Now, can I change 9/4 to a different base? Well, I can simplify the 9 and I can simplify the 4. I know that 9 is 3 squared, and I know that 4 is 2 squared. But be very careful here. Are my bases the same? No. One is 2/3, the other is 3/2. But can I do something to possibly make them the same? Can I take that second fraction and can I flip it? And if I flip it, 3/2 will become 2/3. So I'm going to get 2/3 to the x equals, I'm going to flip it, 2/3. But when I do that, both of these exponents are going to become -2. Whenever I flip a fraction, take the reciprocal, then that means that exponent becomes a -2. Now, I'm where I need to be. I have like bases here of 2/3. So all I have to do is take my exponent part, x equals -2. And the nice thing is there's no solving. That is my answer. Okay. And then just one quick thing to remember. When you're using the calculator and you are squaring a number, I have kids that have problems with this every year. You can't, especially a negative number, you cannot put in -3 squared. Your calculator is squaring the 3 and then it's sticking the negative. Okay, -3 squared is -3 times -3, which gives us a +9. If you're going to stick that into the calculator, you have to put it in parentheses. So the calculator knows what you're actually squaring. So be very careful when you're using the calculator. Again, if you have questions, feel free to email me or anything. We will catch back up tomorrow, again on Zoom at 9 a.m. And you can ask me any questions and I can work some more problems if you need to.